In this lesson, we're going to learn how to determine the molecular formula of a compound. First, reminder of the definition of an empirical formula. An empirical formula is the smallest whole number ratio of the elements of a compound. A molecular formula, on the other hand, is the actual ratio of the elements of a compound. To remind you, the empirical formula of N2O4 would be NO2. It is simply the reduced form of that. Note that the mass of N2O4 is going to be twice the mass of this since we divided N2O4 in 2 to get NO2. Likewise, the empirical formula of C6H6 is CH. Again, here we divided it by 6. So this is the molecular formula. This is the empirical formula. Note the molecular formula is going to be 6 times greater than the empirical formula. And for glucose, we can reduce that by dividing it by 6 to get CH2O. Again, this is the empirical formula, the reduced formula, the lowest whole number ratio. This is the actual ratio, the non-reduced form. And again, note the mass relationship since we divided glucose by 6 to get CH2O. The mass of glucose is going to be 6 times the mass of this. That's an important relationship because that is how you are going to determine the molecular formula from the empirical formula. Again, to test your understanding of what a molecular formula is, which of the following are definitely a molecular formula and not an empirical formula? The answer is the last 3 here, since these are not reduced, they are not the lowest whole number ratios, therefore they must be molecular formulas and not empirical formulas. That does not mean that the reduced, the lowest whole number ratios are not molecular formulas. It turns out there is a compound called carbon monoxide, and that is the lowest whole number ratio, so therefore the empirical formula and the molecular formula are the same thing. Again, the main way to find out the molecular formula from the empirical formula is to look at the mass relationships. Here is the lowest whole number ratio of SO2 compared to these others. And if we call the mass of SO2x, the mass of S2O4 must be 2x, S3O6 must be 3x, S408 must be 4x, since they are those multiples of SO2. So the background here is the molecular formula of a compound is always a whole number multiple of its empirical formula. And again, it's the mass relationship that tells you that whole number multiple. And again, test your understanding of molecular formulas. I know I'm belaboring this point a little bit. Which of the following may be an molecular formula of the empirical formula C2H3? The answer is number 1, because it is 4 times greater. Number 2, because it is 1 times. It's a whole number multiple. Number 5, because it is 3 times. And number 6, because it is 4 times. And again, if I asked you what is the mass relationship, the mass relationship is the same as the numerical relationship between the formulas. If C4H6 is 4 times greater than this, the mass of C4H6 must be 4 times greater than that. So if I ask you to calculate the molecular formula of a compound which has the empirical formula of CH4N and has a gram molecular mass of 60.12, first step is to determine the empirical formula mass, the mass of the empirical formula. So we're just going to add 1 carbon, 4 hydrogens, and nitrogen. So this compound has a mass of 30.06 grams, adding up the molar masses from the periodic table. Then we're going to take the gram molecular mass, that is the actual mass of the compound, divided by that empirical formula mass to see how many times greater the gram molecular mass is than the empirical formula mass. Here's the relationship. The gram molecular mass is to the empirical formula mass as the molecular formula is to the empirical formula. So we take the gram molecular mass, divided by the empirical formula mass, and we get the number 2, meaning that the actual formula must be 2 times greater than the empirical formula. And so we take the empirical formula, multiply it by 2, and there we get the molecular formula of the compound, the actual formula of the compound. Let's wrap this up by looking at the same thing in a table form. If I asked you to complete the following table, given these empirical formulas and their gram molecular masses, first thing again is always determine the empirical formula mass. So CH has an empirical formula mass of 13.01. That's just adding 1 carbon, 1 hydrogen. Then we're going to divide the gram molecular mass by the empirical formula mass to see how many times greater the gram molecular mass is than the empirical formula mass. Turns out it is 6 times greater. 78.06 divided by 13.01 is 6. So then the actual molecular formula is 6 times greater than the empirical formula, so it is going to be C6H6. Next one. Again, determine the empirical formula mass, add 5 carbons, 9 hydrogens from the periodic table, we get 69.14. Then we take the gram molecular mass, divide it by the empirical formula mass to see how many times greater the mass of the actual compound is compared to the empirical formula mass. Turns out to be 5 times greater, so we're going to multiply C5H9 by 5, and that is going to give us C25H45. Last one, the empirical formula is C3H4O. The actual mass of the compound is 56.07. We determine the empirical formula mass by adding all the elements of the empirical formula together. Turns out that is also 56.07, so our multiplier is 1. In other words, the empirical formula and the molecular formula are the same thing.